What's up, you data friends? It's Yanis here and welcome to my channel. This video, which is actually going to be a series of videos, is a Python tutorial for beginners in data science. And more specifically, we have all the steps we are going to cover down here. Now, because Python is such a general purpose programming language and it's used by a lot of different functions, like developers, data analysts, data scientists, data engineers, software engineers, all these people do different things using Python. And if you're a beginner in Python and you're trying to isolate the things you need to learn to become a data analyst or a data scientist, it's very difficult because tutorials out there, they teach different things depending on the function. So when you Google for a Python tutorial, you might get a tutorial that is geared towards developers or towards software engineers. Now, this video is going to be geared towards data science and data analytics related code. Right, looking at what we're going to cover in this series of videos, we're going to start by explaining how to download and install Anaconda, Python, and Jupyter notebooks so we can actually write and run our code. Then we're going to go over the Numpy library, which is going to help you understand how Python and arrays work and how math works. Then we're going to go over the Pandas library, where we're going to load a CSV file, so an actual data set from a real business scenario. And I'm going to show you how to investigate that data set and run all the queries you would normally run in a real life scenario. Then we're going to go over joins and unions, so how to bring data together, how to join the data together. Then we're going to go over MatPlotLib and Seaborn library. These two libraries are very useful for data visualization. And at the end, we're going to have individual videos on machine learning. Now, if I was a beginner in Python and I was doing this tutorial, I was going to find it boring up until somewhere here, I would say. So anything from this side, I was not going to really understand. But anything from this side is where we actually load an Excel file and start working with data. So if at the beginning of this tutorial, when we do NumPy, there's things you don't understand why we do them, please bear with me, because those things are very important later on when we use Pandas and every other thing in Python. Right, the structure of our notebook is going to be the same as this one. So we are going to start with NumPy, then we're going to do Pandas, then we're going to do the joins, then we're going to do MatPlotLib, then we're going to do Seaborn visualizations all the way down to machine learning. And if you want to follow this notebook as is, I have deleted all the code and uploaded the notebook in my GitHub page. I'm going to have the link in the video description. You can download this one and start writing code or doing exactly the same thing as I'm doing in this video. And the last thing I have is that if you're passionate about data science and data analytics, then please click the like button, subscribe to my channel, and enable notifications for my future videos. Right, starting with our first step, which is downloading and installing Anaconda, Python, and Jupyter notebook, we need to click on this link. Or you can go into Google and type in download Anaconda, and it's going to be the first selection there. And then you need to select your operating system. So I am on Windows, so I'm going to click Windows, and then I'm going to click download. I can either get the 64 or the 32. My PC is 64-bit, so I'm going to click the 64. It's the same as this one. Then I need to select where I'm going to save it. So I'm just going to save it into this folder over here. I'm actually going to create a new folder and type in Python. So Python, and then I'm going to save it into Python here. So the download is going to start. When it finishes, we need to double click our download, and then we need to click on run. Next, I agree, then just me, next, I need to select the location again. So I'm going to put it on the same location, which it was here, and then under Python, click OK, click next. Directory is not empty. Okay, so it needs to be empty. So let's do another folder within Python. So let's do this one, yeah. And this is going to be, I don't know, Python 2. Then I'm going to go back into installing. I'm going to expand this, select Python 2, click OK, click next, warning, contains one space. Okay, I don't mind. I click on install. Yep, I want to register Anaconda 3 as my default Python 3.9. Click install, and this is going to start installing. And when this finishes, you click on next, then we click next again, and then we click on finish. I'm not going to launch it because I already have it open, so I'm going to untick this and click finish. Now, to launch Anaconda and Python, there is two ways of doing this. The first one is via Anaconda, so you can go into start, type in Anaconda, and this is the app, so the navigator, and this is going to start this UI you're going to see over here. There we go, you're going to see this in front of you. You can click OK, don't show me this again. And in order to launch, no, I don't want to do an update right now. And in order to launch Jupyter Notebooks, which is where we're going to write our Python code, we can either click here, launch, and this is going to open this window on your browser. And then you need to go on the folder you want to create your file, your notebook. So mine is going to be desktop Python tutorials, then into 2022 Python tutorials. And in this folder, I want to create a new Python 3 notebook. And there we go, we have our notebook here where we can write Python code. Now, another way of doing this, let me close a few terminals. So this one, I need to, let me see, close Anaconda, so quit, yes. I'm going to close this terminal, which I have it open. Then I'm going to go into start and type in Jupyter Notebook is going to show up here. And then if you click on this one, it's actually going to open Jupyter directly on your browser. So instead of going via Anaconda, you can come into Jupyter Notebooks from your start button over here. Right, in order to open the file you are going to download from my GitHub page, so if you download this file here, then you can come into Jupyter Notebooks, go in your downloads or wherever you save that file. So in my case, let me close this. Is saved under Python Tutorials 2022 Python Tutorial, and this is the file, Introduction to Numpy and Pandas. If I click on it, it's going to open the file you have just downloaded from my GitHub page. So you can scroll down here and start writing code with me. There we go. Right, now I'm going to close a few windows which I don't need, so I'm going to make things cleaner. So I think anything after this window we don't need. Okay, so we've explained how to download and install Anaconda. Now you should have it in front of you. Next, we are going to do the Numpy library tutorial. So what is Numpy? So Numpy is a package or a library in Python that stands for numerical Python. It is used for scientific computing by using array objects. And its main benefit is that it saves coding time and execution time. So we don't have to write while loops to execute some calculations. And you are not going to understand this straight away. But as we go through the tutorial, I'm going to try to explain why it saves time by vectorizing our operations versus creating for loops. So when we explain for loops, you're going to understand why. Right. What is an array? So an array is a sequence of numbers or characters. So 0, 1, 2, as we see over here. This is a one-dimension array, so it's actually a vector. A two-dimension array is a matrix. And when we say two dimensions, we mean that we have an X and we also have a Y. A three-dimension array is what you see in the picture here. So it's actually three of these matrices together. And then an n-dimension array is when we have multiple matrices. Now we're going to cover the main data types. So when we are creating an array, some of the main data types we can input into those arrays is integers, float, so numbers with decimal places, strings, which is basically characters, dates, and date time. And now if we want to create an array, so I'm going to be showing you how to do this. Let's say I want to pass value of 3 into a one-dimension array. So if I run this now, it's going to run forever because I'm actually not connected. So I can do kernel restart, and then I need to rerun this. And now it worked because I'm actually connected. So I can run this as many times as I want. And what this does is that it saves the number 3 into this I object over here. By the way, to click run, you can either click Ctrl plus Enter, or you can select the cell and click on run over here. So it does, run actually moves to the next cell. So when I click this cell and I click run, you can see it moves, but I'm going to stay on this cell over here. Now, as you can see, we cannot see what this thing did because we didn't call it back. So in order to see number 3 into I object, we actually need to call I back. So what I need to do over here is to say I and then click run. So you can see I is 3. I can also change 3 to like 7 and click run again. And then if I click run on I, you can see 7 is passed into I. The next thing I'm going to show you is a hello world example, which I said we are not going to do. So if we scroll up here, I said I'm not going to cover hello world examples. So I'm going to do a hello Yanis one, which is not a hello world. So I can pass a string, which is text, into my array. So if I run this, you can see hello Yanis is saved in X, and then I call X and we can see that X is hello Yanis. Now when it comes to calculations now, if I try to add I and X, so one of them is a number, the other one is a text, it's going to throw me this error because we cannot add string with numbers. Now, if I want to apply other calculations, which we have the examples down here, I'm going to click run. You can see that we've passed 3 into I, 4 into U, 9 into T, and then we can do all the basic calculations. So as you can see, I can run I plus U. So if I create a new cell over here so I can show you. If I run this one, you can see it does I plus U, so 3 plus 4, 7. If I do U times T, it's going to do 4 times 9, so 36. If I do T minus I, it's going to do T, which is 9, minus I, which is 3, is going to give me 6. And then if I want to do formulas, as we have down here, I can just type them and it's going to do all the calculations. So I plus U. By the way, I forgot to scroll in, so I'm going to increase the size so you can see this more clearly. Sorry, I forgot to do it from the beginning. Apologies. Now, the next thing we can do is to create an array without Numpy. So something I need to note is that we still haven't imported the library Numpy. I'm just on native Python now, so I can show you the difference before and after installing Numpy. Now, if we run this array, what this is going to do is that it's going to store 1, 2, 3, and 4 into I, and this is a one-dimension array. So this is a vector. Now, if I try to do calculations without Numpy, so if we do the I times U first, so I is 1, 2, 3, 4, U is actually 4, what you see is that it's going to return this array 1, 2, 3, 4 U times. When we say U times, we mean 4 times. So this is 1 time, this is 2 times, this is 3 times, and this is 4 times. So it didn't actually select U, which is 4, and did 4 times 1, 4, 4 times 2, 8, 4 times 3, 12, and then 4 times 4, 16. It actually repeated the array, the vector, 4 times. So this is without using Numpy. If I call Numpy now and I run that calculation, we're going to get what I have just explained. By the way, let's do the I plus 2 so you see the difference again. It says can only concatenate list and not integer to list. And this is because it treats this I vector as a list. So we cannot really apply calculations on it. We can only do times, which is basically going to return the list U times. So U is 4, so 4 times. Now, if we want to apply calculations, we're going to have to do a loop. This is the for loop I have over here. And this is what I said at the beginning when we introduced Numpy. So we said one of the reasons we use Numpy is to save coding time and execution time. So not run these while loops over here. But I'm going to show you the loop first, and then I'm going to show you what happens when we do it with Numpy. Right. To explain this loop now, the first thing I've done is that I created my I. So if I, undo, I copy and I paste this. Our I is the same as before, 1, 2, 3, 4. Then I create this I plus 2, which is an empty object. So if I call it, you can see it's an empty object. And in this empty object, I am going to save our results. Then I move into my for loop. So I say for S in range. So in S, I can put any character we want. I can say I can say U, T, anything here. But I'm going to say S for S in range 0 to the length of I. So let's explain the length. So if I run the length first, you see what's going to return. The length of I is 4. And this is because it's counting 1, 2, 3, 4, and then the range between 0 and length of I is actually going to be the range between 0 and 4. So 0, 1, 2, 3, and it's actually four times, but because we start from 0 is 4 times. So if I print the S, which is how this loop is going to start, so if I copy this and clean this, so we do it step by step. So if I do this, you can see it loop through 0, 1, 2, 3. So this is the range of 0 to the length of I. 0, 1, 2, 3, which is 4 times. Now we need to apply a calculation because all we've done is just loop through 4 times and did nothing, no action. So the next action I want to do is that I want to take the I of S, and just to show you what this I of S is, if I call it alone, I get a number 4. And this is because S has a number of 4 the last time I've run it, because it does 0, 1, 2, 3. Sorry, S has a number of 3, not 4. But number 3 in order of my I is number 4. So 0, 1, 2, 3 is number 4. By the way, if we change this to different numbers, so let's do 6, 7, 8, and 9. So we don't confuse zeros and 1 and 2. So again, when we check the S of 3, which is 0, 1, 2, 3, I of S is going to be the 4th number from my array, which is number 9. So if I run this, it's 9. And what X does is that it takes the I of S, so it starts from 6 because S is going to start from 0, and it's going to do 6 plus 2, 8. Then it's going to do 7 plus 2, 9. And if I run this now, the last number of X is actually going to be the last number we've looped through because we haven't saved anything. So if I run X now, you can see that X is 11. So 9 plus 2 over here. And the last thing I want to do is to append my empty list. So I save this loop, this X, somewhere. So what this does is that the first time it's going to run, it's going to do 6 plus 2, and it's going to save it into this array, I plus 2. So we're going to have 8, 9, 10, and 11 into our I plus 2. And if we run this, sorry. By the way, when you create a for loop, everything within the for loop needs to be a tab in, and then if I come a tab out, is outside of the for loop. So if I run this, you can see we created this array 8, 9, 10, and 11. And all we wanted to do is to take our array, which has 4 numbers, and apply a plus 2 into our array. However, without Numpy, Python needs to go through this while loop in order to achieve this calculation. Now with Numpy, I'm going to show you how Numpy is going to work. If it's the first time you're using Numpy, you're going to have to install Numpy before you call it. And in order to install Numpy, you can either type in pip install Numpy and run it over here, or you can install it via the terminal. Now this is saying that the requirement is already satisfied because I already have it. So I'm going to comment this out and run it. And also via the terminal, you can go into start, type in Anaconda, and then launch the Anaconda prompt, which is this over here. Right click, run as administrator, click yes. And then over here, you can type in pip install numpy and then run this through the terminal. And this is going to install numpy. Right, after you install it, then you have to call it. And in order to call it in your notebook, you need to write import numpy as np. I also have OS here, which is the operating system, which helps with some operations. So we want to run this. You see it run, it's not going to return anything. And then we're going to go and create the same array. So in order to create a numpy array, you need to say np.array and then pass the values into the array. So same thing as before, but now we need to say np.array and we have I. Now, if we run I plus 2, you remember that we got an error with I plus 2 before, which is this error over here. I plus 2, we get the error. Now, if I run this I plus 2, see what happens. So it takes 2 and it applies 2 plus 1, 3, 2 plus 2, 4, 2 plus 3, 5, 2 plus 4, 6. And also we can do the times. So what we have over here, I times U, and let's see what we're going to get. So if we do a new cell and we do I times 4, which was U before, let's do U, so it's the same. U is still 4. You can see that it did 4 times 1, 4. 4 times 2, 8. 4 times 3, 12. And then 4 times 4, 16. Versus the result before numpy, look at what we got. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So this is exactly what we said at the beginning, that we use numpy for vectorization and matrix operations, and also to save coding time and execution time. Because all I've done with numpy, it was I plus 2, and I got the calculation straight away. But without numpy, I had to write all this for loop in order to get to my result. And later on, when we use actual data, so if we open the actual data we're going to use, a vector is going to be one of our columns. So in our case, a vector is going to be the car price over here. So all these columns is going to be one of our vectors. And if we want to apply calculation on all these columns, so price times 2, for example, all we need to type in is price times 2 versus the for loop we had to write without numpy. So this is why numpy is important to understand before we move on. Moving on now, we can apply the same calculations as before, but now our I is not one number, it's a whole vector. So if we scroll up, before we had I equals 3, that's why we were able to do all these formulas. But now our I is a whole vector, and all of our calculations we have over here, they are going to return 4 numbers, because all of these calculations are going to be applied on the whole vector. Without numpy, we were not able to do this, but with numpy, we are able to apply all these calculations in the whole vector. And if we check quickly, I plus U, you can see it's an array of 4. U times T, again, is going to be an array, U and T, they are standalones, they don't involve I, so it's not going to be the whole vector, but T minus I is again going to be 4 calculations. Same with this one, same with all of our formulas. So you can see it's always going to be an array of 4 numbers, because we apply all these calculations in the whole array. Right, the shape of our array now, if I run it, is going to be 4, because we have 4 columns, let's say. So 1, 2, 3, 4, you can see them, 1, 2, 3, 4, comma 0. We don't have anything below because we don't have number of rows. So imagine the shape as first the columns and then the rows. And this is very helpful because later on, when we have a whole array of this big, we want to know how many columns we have. So I don't know, 6 columns and then 300 rows. So the shape is going to say 3 columns, 600 rows. So 3 and 600. Moving on, we have the indexing. So selecting specific elements from our array. So if we run 0 of I, is going to select the first number we have into our I. And if we bring I again, let's bring I down here so we see it again. Here we go. So the 0 of I is the first number. So 0, 1, 2, 3. So 0 is actually 1. So minus 1 of I is going to be the last number. So it's going to start from the end if you add the minus. And I of 3 is actually going to be 0, 1, 2, 3. So it's going to be number 4. If I run it, you can see number 4. If I try to select the fourth number of I, is actually going to return an error because we start counting from 0. So this is 0, 1, 2, 3, and then number 4, it doesn't exist. It throws us an error. To avoid this error now, we can write this error check, the try and except. So the idea behind try and except is that we try to run some code. If this fails, we go to except and we're going to run a different code. So what this is going to do is going to try to return the fourth element of I, otherwise print the error. But if it didn't error, we don't have any action. So if we change this to 3 and run it, you can see there's no action. But we also need to say print and then I. So we are actually going to add an action. So to return the code if it works. If it doesn't, return the error. Right, the next thing we have is to change the elements of the array. So let's say I want to change the first element, so number 1 to number 300, as I have down here. The way to do it is to select the element, so 0 of 1, and then say equals, and then the new number. So what this does, it replaces number 1, which is what we had before, with number 300. Next, we want to show how to create a two-dimensional array. So the way to do this, if we run it quickly, is to say np.array and then open 2 square brackets versus 1. So before we had 1 square bracket, np array, you can see 1 square bracket and then the whole array. But now we need to open 1 square bracket for the first one and then another for the second one, which makes it 2 square brackets and then 2 square brackets at the end. And if we print this, you can see that we have 1, 2, 3 as the first array and then 1, 2, 3 as the second array. So this is a two-dimensional array. If we print the shape now, you can see that we have 2 columns. So that's the first one and that's the second one. And then 3 rows, so 1, 2, 3. And just to show you how this array was going to look in Excel, if I go into Excel quickly, we were going to have 1, 2, 3 as our first array, which is, if I go back, this one, 1, 2, 3, and then another one, 1, 2, 3. So it's like we have 2 columns and then 3 rows as the shape returns. Right, moving on, we can apply the same calculations as before in our two-dimensional array. So if I run a plus 2, because our a is a two-dimensional array, it's going to add 2 into all of our elements. So 2 plus 1, 3, 2 plus 2, 4, 2 plus 3, 5, and then the same for the rest. We can also apply the same calculations as we had before into our two-dimensional array. So these are the pluses, the minuses, the divisions, and then the times and the formulas. And then the same idea with the three-dimensional array. So if I run this quickly, you can see that, actually, let's run it bit by bit. So first we create a three-dimensional array. So 1, 2, 3, 1, 2, 3, 1, 2, 3. Then we can test the calculations. So if I do plus 2, you can see it did a plus 2 in our three-dimensional array. Now, if we want to flatten this matrix, so make it from a 3 by 3 into one array, so combine it together, we can type in this np.h stack and then pass a into it. So if I run it alone, you can see that it took this 1, 2, 3, 1, 2, 3, 1, 2, 3, three-dimensional array and it turned it into a one dimension. Now, if I run it on different cells, so you can see it. So if we remove this and we don't run the +2, so we run just A, you can see that A here is 3 dimensions, and then by running this H stack A, it becomes 1 dimension and it combines these 3 dimensions together. Right, moving on, we can also create an array from a list. So if I create this list, A list equals 1, 2, 3, 4. So before we used to say mp.array, now we don't. We just put the square bracket and we put our list. So again, it happens when you work with data sets. Sometimes you get a list and you have to make it an array in order to apply calculations. So now we can say mp.array and then pass the list into the array and then save this into A. So if I print A quickly, so if I do this and then I run it, you can see that it's a 1-dimension array with 1, 2, 3, and 4 as elements. And also if I want to specify the type now, so I want to make sure that these elements are float, for example, so they're going to have decimal places, I can do the same thing as np.array, but I can also specify the type. So if I add the comma now with the type, you can see that it's 1 dot, 2 dot, 3 dot, and 4 dot, because now we have decimals, not integers. Right, moving on, if we want to create an array from 0 to 100, for example, we can use the append as I have here. So first I create an empty array, so A is like an empty array. Then I say for I in range of 100, so the range of 100 is from 0 to 99, so it's going to loop 100 times like this. And then each time I am appending my A, so I say A equals np numpy.append my A, comma I. So it's going to store I into each time we run a loop. So this is going, if I run it, sorry, if I print it too, so you see what it's going to do, it's going to create an array from 0 to 99 that has 100 elements in it. Now I can apply calculations on this array, so A plus 2, for example, and it's going to add 2 in all of these elements. Now, I have used this sometimes when I had to create a dummy column, so a new column here that is going to help me with calculations. So this is one example of using this append. Moving on, we have array indexing, which is not something I often do at work, but I'm just going to show it quickly. So indexing is when we select a specific value or a specific row or a specific column from our array. So first we create a dummy array, so mp.random, and then I say 5 by 5, so it's going to create a 5 by 5 matrix times 100 because it's very small numbers, and then I also round it so I don't have any decimals. So I've just quickly created this 5 by 5 matrix. If I print the shape, you can see it's 5 by 5. And the first thing I have here is that, let's say I want to select number 67. So let's say I want to select it from the third row, the first number. So always the first number we put is the row. So 0, 1, 2, 2, and then 0, 1, 2, 3, 4. So if I say A square bracket 2, 0 is going to do 0, 1, 2, and then 0 is this number over here, 67. Now, if I run 0, 2, then it's going to do 0, so it's going to stay here, 0, 1, 2, 34 dot, which is 34 dot. I can also select a whole line by saying 0, 2, 2, and then comma nothing. So this is going to select 0 up until 2, so it's going to select 0, and then 1, and then 2 is going to stop just before 2, so it's selecting the first 2 lines, and then the second one selecting the second array line alone in order to do this. is 0, 1, 2, 3, 4. So it returns the 4 line alone. It's actually not the second array, it's the fourth. So I'm just going to say fourth here. Right, this is not something I often do. Usually we index the data frames, which we're going to show in the Pandas tutorial later on, but it's good to keep in mind because it's the same indexing actually in Pandas too, so you're going to see it later on. Right, looking at the data types now. So if I run this, the first one is integer because it's solid numbers, no decimal places. So to check the type, all I have to say is say a.dtype after I create my array. Now, if I add the dot, it means it's a decimal. So 1.2, for example, 2.3, 3.5. If I run it again, you can see because it's decimals, we get float. And then we can also specify the data type, which is something we've shown before. So again, it's float. Actually, yeah, this you see it's solid numbers, so no decimals. But because I said float, if I run a now, it's going to have the dot. So you can see a.2.3. Right, checking at the basic maths now, it's something we have done before, but now instead of adding a single number to it, we're going to add two arrays together. And to do this, if I create the arrays first, and then I run a plus b first, so you see what's going to happen. It did 1 plus 7, 8, 2 plus 8, 10, etc., etc. If I add another number now, so if I add 11 here, and then I run a plus b, you can see it throws me an error because it says the first array has 6 values and the second array has 7. So this cannot work. So I'm just going to delete it again, run it, and then run a plus b. Another way of doing it is by saying np.add. So numpy.add is going to add the two arrays together, which is the same as the a plus b. Right, so we've done this, then we do the minus. It's the same thing as the add, but instead of saying np.add, you can say np.subtract, same thing, multiply, the same thing, and then division, the same thing. We don't need to spend too much time here, they're very self-explanatory. Now, if we want to sum the array all together, so first we create an array which is a 3 by 2, so if we do the shape of this array, you can say it's a 3 by 2 array. If I want to sum all the numbers within our array, I can just say np.sum my a, and this is going to sum everything within my array. So if my array was like 3 columns here, like this, if I do np.sum and then I put all these columns in, it's going to sum all the columns into one number, as we see over here. Now, if I want to sum the values by column, so what I want to do here is that I want to sum the first column, so 1, 3, and 5, and then the second column, 2, 4, and 6, I can say np.sum axis equals 0, and this is going to sum 1 plus 3, 4, plus 5, 9, so 9, and then 2 plus 4, 6, plus 6, 12, so we get 12 over here. And if I want to do the same thing but by row now, so the first row, the second row, and then the third row, I can say axis equals 1, and it's going to sum it by row. Right, next we have reshaping and transpose. So our A is a 3 by 2 shape array. So we have 1, 2, close brackets, 1, 3, 4, close brackets, 5, 6. And let's say I want to take these 3 columns, 2 rows array and reshape it into 2 columns and then 3 rows. In order to do this, we can say a.reshape 2 by 3 instead of 3 by 2. And if we run this, actually wait, let me run A again because I've run something else. So this is our A. And then if we run our reshape, you can see that instead of having 1, 2, close brackets, 3, 4, close brackets, 5, 6, now we have 1, 2, 3, and then 4, 5, 6. So 1, 2, 3, 4, 5, 6. The next thing is the H stack. So we've shown this, how to take all of our arrays and combine them into one. Next, we can also reshape as we create the array. I've never used this, but let's show it. So let's say I create this A, so it's an array of 0 to 10, so 0 to 9, so 10 elements. I can also reshape it at the spot. So let's say dot reshape a 2 by 5. So you can see it's a 2 by 5. If I make this 20, for example, I can make it a 4 by 5 because 4 times 5 is 20. If I put anything else here, so 4 by 4, let's see, it's not going to work because we have a size of 20. Because we have a size of 20 and a 4 by 4 is 16. So they have to match. If I put 16 now, you can see it's going to match. Next, we have the transpose. So let's say we create our A, which is a 4 by 5 matrix, and I want to turn the rows into columns. So I want to reshape it into 5 by 4. Another way of doing it is by saying A dot T capital, and this is going to do the transpose itself without saying dot reshape. So dot T, it's actually doing the same thing as the transpose without having to specify what I have to change. But the difference is that this one is always rows to columns versus the reshape where you can pass different shapes as long as the size matches. So another way of transpose is saying np.transpose and then pass the A into the brackets. And the last thing we have into Numpy is the broadcasting, which allows Numpy to work with arrays of different shapes when performing operations, arithmetic operations. So what this means is that, let's say we have our A, which is a 5 by 3 matrix. We have our B, which is just one vector, one array, one-dimensional array, so a vector. If I want to times this vector with this array, I can just say A times B. And what this is going to do is going to multiply every single column from this array with 5, 2, and 1. So 5 times 0, 0. 2 times 1, 2, 1 times 2, 2. Then we're going to do 5 times 3, 15, 2 times 4, 8, and then 1 times 5, 5, etc., etc. Same thing applies with the plus, and the same thing applies with any other calculation you want to run. Now, maybe you don't understand why I show these things, but later on when we do pandas, and we show this on a data frame, you're going to understand why this broadcasting is actually very beneficial and it saves us a lot of time. If you've made it this far now, well done. You got the boring stuff out of the way, which is the Numpy one and understanding all these arrays and the calculations. In the next video, when we're going to cover pandas, you're going to understand why we had to go through all of those things in Numpy. Actually, not just pandas, MatPlotLib and Seaborn and machine learning. You're going to understand why we need to understand these Numpy arrays. Right, I hope you've enjoyed this tutorial and you've gained enough value out of this tutorial. If you feel like you did, please click the like button, subscribe to my channel, and enable notifications for my future videos. If you have any comments or any thoughts or any questions, please let me know in the comments below. In the next video, obviously self-explanatory, we're going to do pandas, then joins, MatPlotLib, Seaborn, machine learning, and some of the extras. So as we go forward, I'm going to be posting videos on these steps. Right, thank you very much for watching this video, and I'm going to see you in the next video.